In this section, we are working with circles and sectors, and we'll discuss what you need to know on the SAT. You will learn to find the circumference and area of a circle. You will find the arc length and area of a sector. You will recognize that a radius and the tangent to the radius form a right angle, and use that fact along with facts about special triangles to find segment lengths. You will also find the perimeters and areas of figures containing circles and semicircles. A radius is the distance between the center of the circle and a point on the circle. In the figure below, A is the center of the circle, and points B and C are on the circle itself. Hence, AB and AC are radii. All radii of the same circle are congruent, hence AC is congruent to AB. Also know that a radius is half the length of a diameter. The diameter of a circle passes through the center. Both endpoints of a diameter lie on the circle. In the drawing below, segment CD is a diameter passing through the center A. The diameter is twice the length of the radius, or put another way, D equals 2R. The formulas you will need for the circumference of a circle are C equals 2 pi r or pi d, where r is the radius and d is the diameter. The area of a circle is pi r squared. The circumference of a semicircle is pi r, and the area of a semicircle is 1/2 pi r squared. In the figure below, the segment highlighted in red is arc BC. The entire area outlined in both blue and red is sector BAC. Here are the formulas you will need for arcs and sectors. Notice here that x is the degree measure of an angle that subtends the arc. Let me emphasize the angle is measured in degrees and not in radians. The arc length is x over 360 times 2 pi r, and the area of a sector is x over 360 times pi r squared. The problems below give you some practice working with the formulas for arc lengths and sectors. We are given a circle with radius 4 and a central angle of 30 degrees. Find the arc length determined by the angle and find the area of the sector BAC. The arc length is x over 360 times 2 pi r, which is 30 over 360 times 2 pi times the radius 4, and that becomes 1 over 12 times 8 pi, which is 2/3 pi. The area of the sector is x over 360 times pi r squared. That equals 30 over 360 times pi times 4 squared. 30 over 360 reduces to 1/12. 4 squared is 16. We have 16 pi over 12, which reduces to 4 pi over 3. Here's an example. A circle has a diameter of 6. Find the circumference and the area. The circumference equals 2 pi r or pi d. Since d equals 6, we can say that the circumference equals 6 pi. The area is pi r squared, and the radius equals half the diameter. Because the diameter is 6, the radius must be 3. The area equals pi times 3 squared, which is 9 pi. And let me emphasize, to find the area, you must use the radius and not the diameter. In this picture, we have a circle with radius AD and a line that is tangent to that radius. You need to realize that angle ADE is a right angle. This problem will give you practice dealing with this principle. A circle with center A has a tangent line intersecting the circle at point B. Find the length of DC in the figure below. The figure is not drawn to scale. The hint is, what is the measure of angle ABC? Because it's formed by a radius and a tangent line to that radius, the measure of angle ABC is 90 degrees. Because we know from the figure that angle A is 60 degrees, angle C must be 30 degrees, and we have a 30, 60, 90 right triangle. Now we can use the facts about special triangles. If the shorter leg AB is 3 units long, the hypotenuse AC must be 6 units long. Notice that AD is also a radius and hence its length will be 3. If we subtract the values, we can have the length of AC, which is 6, minus the length of AD, which is 3, and this tells us that CD is equal to 3. In this figure, a semicircle has been joined to a square of length 4. What is the perimeter of the figure, and what is the area of the figure? The trick here is to realize that segment AB is not part of the perimeter. The perimeter of the figure equals the perimeter of the semicircle plus the perimeter of the base. The perimeter of the base is the 3 sides of the square. All 3 sides have a length of 4. There are 3 of them. Hence, the perimeter of that part is 4 times 3, which equals 12. The perimeter of the semicircle is pi times the radius, which is pi times 2, or 2 pi. Note that the total perimeter is the sum of those values, which is 12 plus 2 pi. The total area equals the area of the base plus the area of the semicircle. The area of the base is s squared, which is 4 squared, or 16. The area of the semicircle is 1/2 pi r squared, which is 1/2 times pi times 2 squared. 2 squared is 4, half of that is 2. Hence, the area of the semicircle is 2 pi. The total area of the figure is the area of the base plus the area of the semicircle, which is 16 plus 2 pi. Given a circle of radius 5 and a central angle of 90 degrees, find the area of the shaded region. The area of the shaded region equals the area of the sector minus the area of the triangle. The area of the sector equals x over 360 times pi r squared, which equals 90 over 360 times pi times 5 squared, which is 1/4 pi times 25, or 25 pi over 4. The area of the triangle is 1/2 base times height, which is 1/2 times 5 equals 25 over 2. And if we want to express the final answer as one term instead of 2, we'd need a common denominator of 4, and 25 over 2 would become 50 over 4. The area of the shaded region is the area of the sector, which is 25 pi over 4, minus the area of the triangle, which is 25 over 2, or 50 over 4. If we subtract, we can get an answer in one term, which will be 25 pi minus 50 over 4. Given a circle with diameter d, find the area. Recall that to find the area of a circle, we need the radius. If the diameter is d, the radius is 1/2 d. The area is pi r squared, which is pi times 1/2 d squared, which becomes pi times 1/4 d squared, which can be simplified to pi d squared over 4. Here are some practice problems for you to try. Pause the DVD after each problem. When you have found an answer, come back and check it. Here are practice problems 1 through 4. And we're given a circle with a diameter of 8, and we're asked to find the circumference, to find the area, and if a 60-degree angle has been drawn in the circle, find the length of the arc subtended by the angle, and find the area of the sector that's been created. Here are the answers to problems 1 through 4. The circumference equals pi d, which is simply 8 pi. The area equals pi r squared, which is pi times 4 squared, which is 16 pi. The arc length is 60 over 360 times 2 pi times that radius of 4. That becomes 1/6 times 8 pi, which is 4/3 pi. The area of the sector is 60 over 360 times pi r squared. 60 over 360 reduces to 1/6. 4 squared is 16. Therefore, we have 16 over 6 pi, which reduces to 8/3 pi. In problem 5, given the circle with a central angle of 60 and a radius of 6, find CE. The answer to problem 5 is 6. Recall that the radius equals 6 and the central angle equals 60. Note that the triangle is a 30, 60, 90 triangle. Therefore, the hypotenuse is twice the radius and is 12. Since we know that a radius is 6, then by subtraction, CE equals 12 minus 6, which is 6. In problem 6, find the measure of angle X. The answer is 80. Since two of the sides are radii, the triangle is isosceles, and both base angles equal 50. 180 minus 50 minus 50 equals 80. Here are the last group of problems, 7 through 10. We're told that the area of a square equals 81 square units, and we're asked to find the side length of the square, the length of the square's diagonal, the length of the radius of the circle, and we're asked to find the area of the circle. The side length of the square is the square root of the area. The square root of 81 equals 9. When we have a diagonal cutting a square, we get a 45, 45, 90 triangle, and the diagonal is just the hypotenuse of a 45, 45, 90 triangle, which is the side times the square root of 2. Since the side length of the square is 9, the diagonal is 9 square root of 2. The radius will equal 1/2 of the diagonal, which is 9 square root of 2 over 2. The area of the circle is pi times the radius squared, which is pi times 9 over 2 square root of 2, which is 81 over 2 pi.